two packing crates are connected with the same string, which is passing over the frictionless pulley, as well as this surface is also frictionless, which means that as it is also written here that it's a smooth surface, all right, which means there is a no force of friction will be applied on a crate that is dragging or that is moving on this inclined plane or ramp. All right. Now, another thing before we start the question, if you see this, uh, this is a string that is passing over the pulley. All right. So the force of tension is same. Okay, the magnitude of force of tension is same at both ends. So this is a direction of force of tension at this end, whereas this is a direction of force of tension at the other end, where it is attached with a 5 kg crate. So I'm saying that their magnitude is same, although their direction is different. Okay, now in this question you have to find out acceleration of 5 kg. Okay, by the way, acceleration of 5 kg is same as the acceleration of 10 kg. Once again, the difference is the direction. Okay, so it is moving in the opposite, like the vertically downward. That's why it will have a negative acceleration, whereas this acceleration will be also negative. I will tell you why, but the magnitude of acceleration will be same. We have to find its value, as well as the tension in the string. So once again, the same procedure to solve any force question. We will start from the free body diagram. The free body diagram will give you equation which you will solve, and you can find the tension and the acceleration. So we have, students, two unknowns: tension in a string as well as acceleration in the package 5 kg. Okay, so we are going to start from the free body diagram of this. Okay, so this is the 10 kg package, and as I told you that it's accelerating down, which means that the downward force must be greater, which means its weight. Okay, so its weight, which is let's call it capital Mg, must be larger than the upward force. And look, I told you that this is a force of tension. All right, force of tension. Now we can make equation, because this is this is an example of unbalanced force. So if we apply Newton's second law, then we can say Ft positive plus into negative mg is equals to m into negative a. All right, properly, if you write equation according to Newton's second law, this is the resultant force. Okay, this is a net force applied on 10 kg. So for this package that is placed on inclined plane, our rectangular coordinate system is also inclined, tilted at an angle 40 degrees. So we will consider this is a 5 kg. Now how many forces are exerted on it? So dear students, this is obviously the force, that is the weight. So I'm writing small mg. Okay, and this is another force, that must be the normal force. So normal force, as it is frictionless, so there's a no force of friction. These are the only two forces. No, there's a third force. Dear students, you know that that must be the force of tension, and I am going to draw the same length of arrow. Okay, you remember this one is a force of tension. Now in the next diagram, I'm going to split the weight into its components, because we want to write an equation. Okay students, so let's see in this diagram. This is an angle, which is an angle of this ramp, that is 40 degrees. So when you will make its components, so there will be the obviously the two components. The one that lie on a y-axis is the y component, and that must be mg cos 40 degrees, right? And the component that lie on x-axis must be the x component. So when I have splitted the mg into its components, so that's why I'm going to remove now mg. All right, because we have already made its components. So that's sine 40. Now you see in this diagram, the force of tension is more than mg sine 40. That's why this package 5 kg is accelerating up on the incline. So students, what do I mean? That the force of tension on this 5 kg is bigger than the mg sine 40. Okay, so which means that this is a resultant or the net force for the 5 kg. So what is the resultant? If you follow the sign convention, right? So mg sine 40 is obviously a positive force because this is on a positive x-axis, plus into negative ft. All right, the force of tension is equals to the m into negative a. All right, once again I'm actually following the sign convention that the positive force is the one that is on a positive x-axis. So as it is accelerating along the negative x-axis, that's why I have written here negative a. Okay, once again, you, like as per your convenience, you can also write this equation, which will be perfectly fine, that mg sine 40 is equals to ma. All right, so if I plug the value of mass, so this gives us the force of tension minus 31.5 is equals to 5a. All right. Once again, this is our second equation. And students, if you add these two equations, right, notice that the one in a one equation we have a negative force of tension, in another one we have a positive force of tension. So when you will add these two, it will cancel out the force of tension, and what we will get? We will get 98. All right, minus 31.5. I have cancelled force of tension, is equals to 5a plus 10a, which is 15a. All right, so from here you can easily find out acceleration in the packages. So acceleration is 4.43 meter per second square in the packages, right? Now, if you put the value in any of the equation, for example, in this equation, so if I put the value of the acceleration is equals to 5 into 4.43, and then you can take this negative 31.5 on the other side, and the force of tension will be, its magnitude will be, so it is 53.65 newtons. Okay students, so this is our final answer. I hope you understand every point, and if you have any question you can just email me. All right, thank you, bye.